Hello, hello, everyone. I see you all trickling in. For those of you joining us via the recording, hello as well. We're going to give everybody a couple more moments to jump in, and then we will go ahead and get started. My name is Anna Richmond. I work on the customer success team here at Tutor.com in the Princeton Review. And so that means if you are coming from a school district, a library partnership, even from our military partnership, that your school administrator works with one of us on our team to share this sort of information with you. Joining me today and presenting this wonderful session for us is Stacy Cowup, and I will let her introduce herself here, and then we can get started. If you have questions at any point as well, feel free to put them in the chat or the Q&A section. Please do not be afraid to interrupt. We want to hear from you. If you've got a question about this exam, we are happy to answer that for you. Thank you, and Stacy, take it away.
Thanks, Anna. Welcome, everybody. Today I'm going to talk to you about the AP Science exams and what's involved and what you have to know. My background is I've been here at Princeton for over 20 years. I have my I did engineering as undergraduate. I have a master's in business. I have a master's in engineering also. And I spent 8 years as a project manager in the aerospace industry. I spent 5 years as a project manager in the software industry, and then started working with Princeton, and I've been here ever since. So my full-time job is I work for Princeton Review. I teach and I tutor. I do high school, ACT, SAT. I do college, GMAT, LSAT. And I tend to focus on math and science. I do physics for the MCAT. I do physics for AP exams. I do physics tutoring. And I'm also the senior content developer for the AP Physics 1 test here at Princeton Review. So thank you for joining us today. And let's start talking a little bit about the AP Science exams and what's involved. So 3 main points that I'm going to be making today in this presentation is why might someone want to take an AP exam? Then I'm going to talk a little bit about understanding the exams themselves, what they're composed of, how they're put together, and then talking a little bit about how to prepare for these exams, right? So let's start with why would one want to take an AP exam? All right. One of the major points why you would take an AP exam is you can earn college credit. Now, what I want to do is I want to be really specific about how this works at colleges. So most colleges have a requirement for how many units or credits you have to take while in residence in order to get a degree. So if you're coming in with certain AP exams, you won't earn credits that go towards your degree because you have to earn them while physically at the college. But what you usually do with AP credits, and AP exams are graded on a scale of 1 to 5. We'll talk a little bit later about the numbers and what they mean. Most colleges will give you credit for having the knowledge necessary for the course material for a 3 or higher. And you'll get essentially the credit for required courses. And most of the time, what this means is you get to skip the intro courses. So maybe you're majoring in biology and you've done AP biology class. This way you can get out of, Bio 101 or the introductory course and get into the more detailed courses around your major. You want to maybe specialize in either pre-med or pre-vet. You can get into the particular classes for your particular degree requirements. All right. Sometimes you can even, with enough AP credits, you might even be able to get out of college instead of in 4 years, maybe 3.5 or even 3, depending on how you can arrange things, put them together, maybe take a class or 2 over the summer. All right. And given how expensive college is these days, anything that shortens the amount of time you have to pay that bill are things that we always really look hard at. All right, college, very expensive. So one of the primary reasons to take AP exams is to earn credit from a school that allows you to move beyond the introductory course. So let me get out of intro, bio 101, and let me get into the more advanced courses in the areas that I want to focus in. So AP exams are offered once per year in the May timeframe. All right, they're generally the middle 2 weeks of May. And for today, we're going to talk primarily about the exams that you see on the board. We have chemistry starts on Monday the 6th. We have environmental science on Thursday the 9th. And then those last four exams you see physics 1 and physics 2 on Friday the 17th. And you can see that the physics 1 is offered at 8 a.m. local. The physics 2 is offered at 12 p.m. local. So this way there are folks that are going to take physics 1 and physics 2. And if you notice, the times are local. So the exam is not offered at the same time nationally. They're offered at local times. And then as you can see, there's a different class of physics exam called Physics C, which is electricity and magnetism and mechanics. And those exams are offered a couple days earlier on Tuesday, May 14th. And you can see that mechanics is offered at noon locally and E&M is offered at 2 p.m. locally. And so one of the things we're going to talk a little bit about today is, okay, there's like 4 physics courses here. Oh my goodness, that's a lot of physics courses. How do I know which one to take? And what one are we going to do? There shouldn't be a lot of confusion about which exam you need to take, because in order to take an AP exam, you've been studying an AP course content for the whole year. So some people do it through homeschooling, some people do it in school. The teachers have a curriculum planned out, but taking an AP exam is something that needs a fair amount of planning. You have a certain amount of material you have to cover. So this is not something you just sort of decide to take. Like if I want to take the SAT, I'm like, oh, am I going to take it on, in March, or do I want to take it in May? And, and as long as I sign up for it a month ahead of time, I'm good. That's not how AP exams work. AP exams you have to sign up through your district. They're distributed through official channels. And so as a student, you can't just sign up for an AP exam. All right. So you have to be progressing through an AP course. All right, so let's talk a little bit about how the exams themselves are scored. Like I said earlier, AP exams are scored from 1 being the lowest score to 5 being the highest score. As you can see on the screen, an AP score of 5 means that your test was evaluated and the scores felt that you did an extremely good job answering the questions, and they believe you extremely well qualified for that course content. And they would believe that a 5 is the equivalent of an A or an A plus. So you understood the material, you're very clear, you did well with the questions. An AP exam of 4 is very well qualified. So that ranges from a B to an A minus. An AP exam score of 3 means you're qualified. They believe you understand the content and would pass a college course with that content, and that covers the grade range from C through B minus. As you can see, for an AP exam score of 2, that's called possibly qualified, and most schools will not accept a 2 in order to waive you out of classes. They believe that you have not mastered the content well enough, that most schools are going to make you retake those classes. And an AP exam score of 1, you notice they say no recommendation. They believe that you do not understand the material well enough and believe that the exam, you didn't do very well on it. All right, so 1s and 2s are not AP numbers you kind of want to show to colleges. They're reluctant to see them. But 3s and above can potentially get you out of those introductory courses and get you into the more advanced courses in your major area, which is what you're looking for. So let's talk about these exams and what we're looking at here and what's involved in them. So the purpose of the AAP exam is to show that a student has received the information and is competent in a certain area that they're testing it. All right. So we're talking right now about the science exams, the 4 physics exams, the chemistry, and the environmental science exam. So the purpose of taking one of those is to show that I understand enough material that that would be the equivalent of having taken that semester class in college. All right, so one of the things that AP focuses on in terms of these science exams is they usually have about 5 to 7 big ideas. What are the main ideas being covered in the exam? So from an AP biology, and I apologize because I just realized that I didn't put AP biology on the exam date list, so sorry about that. In biology, we're looking at evolution, we're looking at energetics, information storage and transmission, and systems interactions. All right, for chemistry, this is about pretty much scale, proportion, and quantity, all the different structures and properties associated with chemistry, transformations, how molecules, systems, etc., move from one phases to other phases, and the movement of energy, how energy is stored and used. In environmental science, you'll see that we have some similar, AP environmental science has some overlap with a bio, a little bit with chemistry, so energy transfer. Now here, this is the interaction between the systems on the Earth and then the interactions between the different species in the environment. So environmental science has a lot to do with interactions between species, systems, environments. And then one of the key topics these days is sustainability, right? That's a major topic in AP and also in colleges. Lots of environmental science and sustainability majors. Now, in physics, we have AP Physics 1 and 2, and we have AP Physics C. AP Physics 1 and 2 is an algebra-based physics class. AP Physics C is a calculus-based physics class. That's the main difference. So AP Physics 1 and 2 is focusing on systems, fields, force interactions, change, and conservation. And between Physics 1 and 2, there's just different topic areas to cover. So AP Physics 1 is primarily mechanics, springs and thermodynamics and kinetic and potential energy, where AP Physics 2 is more electricity, magnetism, waves, quantum mechanics, quantum physics, right? So they cover the same big ideas, they just cover them in different topics. And if we look at Physics C, electricity, magnetism, E&M, and mechanics, we'll see some similar big ideas: change, force interactions, fields, and conservation. So you see similar big ideas between AP Physics C and AP Physics 1 and 2. And the topics are going to be very similar. The difference is going to be, okay, is this algebra-based mathematics that are being involved in working the equations, or is this more calculus-based? Right, so if we look at an exam structure, what we want to do is compare sort of what's going on in the different parts of the exam. So for all of the science exams that we've got listed here, section 1 are the multiple choice questions. Right, as you can see in biology, there are 60 multiple choice questions in an hour and 30 minutes. In chemistry, you have 60 in an hour and 30. In environmental science, you have 80 questions in an hour and 30. Physics 1 and 2 are 50 questions in an hour and 30 minutes. And Physics C are only 35 multiple choice questions in 45 minutes, again, having to do a lot with the more complicated calculus base. Section 2 are the free response open-ended questions. And again, you can see differences between how many questions. Biology, you have 6. Chemistry, you have 7. Environmental science, you only have 3, and they're only an hour and 10 minutes. And if you notice that environmental science is the science AP exam that is not evenly split, where 50% of the grade is section 1 and 50% of the grade is section 2. Environmental science, 60% of the grade is section 1, the multiple choice section, and only 40% of the grade is the free response 3 questions. So that's one of the reasons why they have 80 multiple choice and only 3 free response, because of the percentages of the total score in the different parts of the exam. Biology, chemistry, physics 1 and 2, and physics C, as you can see, they're all 50-50. Half the exam scores from the multiple choice questions, half the exam scores from the free response questions. All right, and as you can see with biology, chemistry, and physics 1 and 2, they're all an hour and 30 minutes or 90 minutes per section. Physics C is 45 and 45. All right, again, fewer total questions. Each of the questions tends to have a little bit more work we need to do because it's calculus based. Right, and those are the primary sciences. If you were to look on the AP College Board website, if you go to sciences in general, you'll also find that an additional test under the science category is psychology. We're not talking about psychology today because I don't have an expertise in psychology. I've taught, tutored, and written questions and developed structure for all of these exams. So I'm relatively familiar with all of these. Again, I'm a senior content developer in Physics 1, so I'm very familiar with physics. But I am not the person to talk to about psychology. And so we structured this to talk about the areas that I'm very familiar with. So let's continue on and talk about, now that we understand the basic structure of the test, we want to talk about, all right, how do we prepare for this exam? All right, this is not an exam that you take, like I said earlier, sort of, a month ahead, I decide, oh, I think I'm going to take this. You have to be in an AP course structure preparing, whether it's, physically in the high school or homeschooling. You have to be proceeding through the content, covering the material, completing the lab work. All right, because part of the preparing for the exams is your teacher has your lab notebooks in school, and all that has to be submitted. What I'd like to talk about first is the multiple choice questions. So section 1 of each of the tests are all multiple choice questions. I want to talk about how to approach them, how to look at them, how to think about them. So this chart seems to be, I apologize, seem to be missing a little bit on that chart. But what I want to talk about is what's letter of the day. Letter of the day means if I have no idea what the question's asking me, or I can't get rid of some answer choices, because one of the things we're going to talk about today is process of elimination, how to get rid of answers, then there's going to be, at the towards the end of my test, with about 5 or 10 minutes left of my exam, I'm going to go through my exam and look at the questions that I haven't answered yet. And at that point, I will have, we're going to talk about a 2-pass method and how to approach the exam, but I will have gone through the multiple choice section twice. So at this point, I'm not sure what to do with these questions, but I don't want to leave them empty. I don't want to leave them blank. I always want to put an answer in every question. There is no penalty for a wrong answer. You don't lose any points for a wrong answer. On this exam, you only get points for a correct answer. So you never want to leave an answer blank. And if you're not sure what letter to put in, just on the day of the test, pick one of the 4 letters, A, B, C, or D, and make that your letter of the day. And then for every answer that you're not sure what to put, go put the same letter in all of them. Because I have a 25% chance, 1 in 4, of getting it right. So if for every group of 4 questions that I stick my letter of the day in, I put A, let's say I have 12 questions that I don't know how to answer. I'm going to go put an A, whatever my letter is that day, in all 12 of those questions. Well, I should get about 4 points out of that, about 3 points out of that, because I have a 25% chance of getting it right. So for every 4 questions I put a letter of the day in, I should get one of them right. If I get a point by accident because of my letter of the day, I'll take it. All right. I'll take anything that helps me increase my score. So we don't want you to think too hard about, oh, what letter should I choose here? What letter should I choose here? If you have not eliminated any answer choices and don't know what letter to put in, put the same letter in all the time, fill them in, be done with it. All right. So don't spend a lot of time thinking hard about that. It's not worth it. I mentioned a couple of minutes ago, I was going to talk about the 2-pass system. So our recommendation on how you handle this test is to proceed through each section of the test twice. The first time through the test, you answer the questions that when you look at them, you know what to do. All right. We call these our now questions. When I read the question, I know what I need to do to solve it. I answer the question, I solve it, I move on. If I look at a question and I'm not sure what to do with that question, or I'm not sure how to solve it, it's a later question and I initially skip it. The reason we want to do this 2-pass system is, like I said, there are AP Physics 1 has 50 multiple choice questions. All right. And I have 90 minutes to get through 50 questions. So less than 2 minutes a question. All right. Minute and change per question. That's not a lot of time. What I want to do though is I want to get all the points that I can get. And I want to make sure that I touch all the questions that I know how to do. And that's where the 2-pass system comes to bear. I don't want to get stuck on a question I don't know how to do and not potentially answer 2 or 3 questions that I do know how to answer. So let me give you an example of one of my students did question 1, knew how to do it, got to question 2, wasn't sure what to do. Question 2, 3, and 4 threw him a bit. And he got a little, thrown off, and he ended up spending 15 of his 90 minutes on 3 questions, which is sort of way too much time on 3 questions. At that point, those are 3 questions he doesn't know what to do with. He's now rushing to get through the rest of the exam to find the questions he knows how to do. So that's one of the reasons why, if you look at it and aren't sure what to do on it, on your test booklet, you kind of circle it and move on. This way, I make sure that I see all the questions I know how to do and I get all the points on the questions I know how to do. Once I've gone through the whole first section, touched everything and did every question I know, now I'll go back and deal with the later questions. Right? Employ some of my process of eliminations. Can I get rid of any of these answer choices? Do that. So we go through first, we do everything we know how to do. We get the points that we know how to work. I want all those points in my pocket. Then I'll go back and deal with the questions that I'm not sure what to do with. All right, those are my later or my second pass questions. Now, if you're skipping questions, some people, are bubbling in answers on their bubble sheet. And they're like, oh, I skipped that one. If you're bubbling in as you go, you got to make sure when you skip a question, you skip a row on your bubble sheet. I get a little frustrated with having to make sure, what row am I in? Am I in the right row? I don't generally do my bubble sheet right away. I wait till maybe there's about 10 or 15 minutes left in the test. Then I pull out my bubble sheet, I pull out my test booklet, and I start transferring all of my answers to the bubble sheet. So this way I don't have to be, okay, I skipped one, I got to skip a line on the bubble sheet. That sometimes gets a little frustrating, a little hard to manage. Did I skip the right one? Am I on the right number? All right, let me just work on the test itself, and I'll worry about bubbling later. You can also see, you can do them by page. As I do, a page in the book, I move everything to the answer sheet before I move to the next page. You want to find, as you're practicing and getting ready for May, and as you're doing practice tests in April, right? So most people, teachers are starting to it's this January, so they're still teaching content, and you'll still be teaching content up through the end of April, but teachers will start reviewing certain sections. You want to figure out what works for you, right? When you're practicing this and working on these, what best works for you? Do you want to bubble in after each question, or do you want to kind of wait and then bubble in a bunch? All right, so try it out. Check it a couple different ways as you're practicing. So this way, by the time you get to test day, you're clear, you know what you're going to do and how you're going to handle it. One of the key strategies for standardized testing is the process of elimination. And this is something that we have to get used to as high school students, because in school we're taught, when we look at a problem, we got to look at a problem. How do I solve this? I want to find the right answer. Well, here at Princeton Review, we like to remind you that standardized tests have some things in common, because just because I'm not 100% sure what the answer is, that doesn't mean I might not be able to eliminate some of those answers as clearly wrong. If I can eliminate 3 of the 4 answers, then I've pretty much probably found the right answer choice. So let's look at an example. The question says, what's the capital of Malawi? And to tell you the truth, I don't know what the capital of Malawi is off the top of my head. I have no idea. But if I look at those answer choices, and so if I saw this question and I'm doing my first pass, I would skip this question and kind of circle it on my paper. I'm skipping this. Let's move on. When I come back my second pass, I'm now looking at the answer choice and saying, wait a second, Paris. I know Paris is not the capital of Malawi. I know London is not the capital of Malawi. And I know Amsterdam is not the capital. I know where they are. I know what they're the capitals of. It can't be A, B, or C. So by definition, I'm going to choose D. And in this case, 3 of those answers are clearly wrong. And I've employed the process of elimination. And I'm like, oh, I'll probably get this one right. All right. So process of elimination can help us get rid of, and a lot of times it might not get rid of 3 of the 4, but it should get rid of at least 2 of the 4. And then I'm down to a 50-50 chance, which is a much better than 1 out of 4. Right? So with the process of elimination, I'm now looking for, can I find one of these answers as wrong? I'm looking in the answer for something that's wrong. Now, if you notice, we see that half wrong equals all wrong. What that means is College Board is very good with their standardized testing. They're very good at catching us with things that we make silly mistakes on. So a lot of times what College Board will do is they'll have a fairly long answer that has sort of 2 parts to it. The first part of the answer is right. And most of us are reading through the first part's right. And we don't read carefully enough on the second part of the answer. That's usually where College Board hides some words or phrases that may not be correct in that answer choice. And if I'm rushing too quickly and don't read every word in that answer choice, I might miss that, wait a second, that's not right. That's clearly wrong. And if part of it's wrong, the whole answer is wrong. One wrong word in an answer makes that answer wrong. Every word in the answer has to be correct. So sometimes I can get rid of answer choices because I'm like, well, this is not right. Let's get rid of that one. And again, do not leave anything blank. There's no penalty for a wrong answer. So since I don't get penalized for a wrong answer, like I said, if I've got 12 questions left at the end of my test that I wasn't sure what to put the answers in, and I go put A's in all of them, and I happen to get 3 points out of that, I'll take points that I got by accident, right? Or that by using letter of the day. So I'll take those points because in the end, they're going to help me. All right. So like we said, if I can get rid of even 2 of those 4, I'm down to a 50-50 chance. So I want to be relatively aggressive in my guessing, because as my chances increase in getting them right, the more I get right, so does my overall score. Right? No blank answers on test day. What I'd like to talk to you now about is the second section of the science tests, which we call the free response questions. So I want to talk a little bit about the strategy, how to approach the science tests free response section, and what we have to be careful of in this section. So the first thing you have to do is I have to understand what they've asked me to do. So one of the things that I found with my students is they tend to read the questions really quickly. This is not the part of the exam you want to read the question really quickly and not pay attention to every word there. I want to be very clear about what they've asked me to do and what do I have to do. Plus, there's multiple parts to the question. And I'm usually asked to show my work, right? Prove or show why, or, so I can't just write, is this going to increase or decrease and, show why. I can't just say increase. I'm not going to get all the points for just an increase. I have to show why it's increasing. I have to answer all the parts to a question. So I have to be careful. Does this, A through E? Is this A through C? How many different parts do I have on this question? The more parts on the question, all right, the more parts I can attack. If one of them I'm having trouble with, move on to the next part, right? Because then I've got more points distributed. Right, so now when we're talking about the AP Physics 1 test, and we talk about the 5 questions in the free response section, questions 1 and question 2 are each worth 12 points each. Right, question 1 is an experimental design. I have to talk about what kind of experiment do I need to answer a question or prove a point. Question 2 is going to be a qualitative or quantitative translation. So I'm going to have to take a table of numbers or something and maybe make a graph or show how this data relates to each other. Question 3 is what they call an argument short answer. I have to write a paragraph actually. So I need to be really careful with these questions to make sure I'm reading, okay, what am I supposed to do here? Oh, this is the one I have to write the paragraph on. So I need to, in a paragraph format, write an answer with justifications. And then questions 4 and 5 are short answer questions. Those I can usually, an equation with some numbers. Questions 1 and 2 are worth 12 points apiece. Questions 3, 4, and 5 are worth 7 points each. And so again, if you take question 3, 4, or 5, they might have 3 or 4 parts to it. They're worth 7 points each. Yeah, I might get 1 or 2 points for each of the different parts. So that's why I always want to keep an eye on, all right, if I'm having trouble with A, let's go to B, C, or D. The other thing that's very important with the physics exams and a lot of the AP science exams is the vocabulary that the test uses. So we're taking physics 1 as an example. They use certain words in the free response questions. They say justify. Right? If I justify something, I've got to show and write down on my paper why I think this answer is what it is. So I got to show evidence, which means I have to show an equation or a calculation or I have to provide the logic for why this is the right answer. So I have to justify, support my answer. I can't just write an answer down. Right? Calculate means I got to show you my work. Derive means I have to start with a basic equation and essentially manipulate that equation until I get it in the form that I need to answer a question or show a particular type of solution. Right? What is and determine are nice words on free response because they mean I just have to give you an answer. I don't have to show you all the work to get to the answer. They just have, what is the value of X, Y, or Z, or determine the energy needed for this question. I just have to give an answer there. I don't have to show you step for step how I got from start to finish like I would with a derive or a calculate. All right. For sketch, they put graphs in, right? Literally in the answer book, I might have a small piece of graph paper, and they're going to tell me they want me to sketch a graph that demonstrates, and then they'll tell me, am I graphing the results of an experiment? Am I graphing an expected kind of curve for energy in a certain situation? Right. And I have to literally put in a curve. I have to indicate where it crosses certain axes. Are there any asymptotes that show values that this curve can't be equal to? All right. Then we've got, so sketch is a rough sort of curve graphing. Plot means I've got to put points on a graph. And I've got to literally, plots are usually information relative to an experiment. Plot the results of the experiment shown above. I got to literally plot all the points. And in plotting those points, I have to be really clear about my axes. What are the values on the axes? What are the units that I'm using on these axes? So plot is a more formal response than sketch. Sketch, I could do a rough XY axis and do a line. All right. Plot means I got to get all the axes right, the units right, the points in the right place. The scale of my axes has to be correct. All right. Exam questions, they might ask me for a free body or a force diagram in physics. Right? And notice they say draw and label the forces, not the components that act on the object. So if I have a tension force, so let's say I've got a box on the floor and I've got a rope on my box and I'm pulling that rope to pull my box across the floor. All right. If I'm pulling that rope at an angle. It's not flat in the x-plane or not, it's not horizontal or vertical. It's coming at an angle. So it has X and it has Y components. Those are components they don't want to see. They want to see the force. So I'm expected to draw force at a certain angle that I'm pulling on that rope. Right? If they ask me for the tension in the rope, I got to draw force at the angle that rope is at. Right? Not the x-axis, not the y-axis. So again, I have to understand exactly what these statements mean and how I'm supposed to approach them. And then, like I said, question 1 is an experimental design question. So I have to, in the answer to question 1, tell you what kind of experiment we need to conduct or what kind of procedure has to happen in order to verify some kind of value or principle. And then I have to essentially give you a sequence of what needs to happen in what steps. All right. How does this experiment need to proceed? What type of measurements need to be taken? What kind of results are we expecting to see? All right. So that experimental design question is something students have to practice. This is not something I found with a lot of my students. This is not something that we can do off the cuff. Most of us are not used to writing how an experiment needs to proceed. So this is the kind of question we absolutely need to practice so that when we see this question on the test, we know exactly what we need to provide. So in the free response question, you always want to explain, all right? You never put a number down with nothing behind it. You always, and a number comes out of an equation or a calculation, or, where did this number come from? How did I get to this number? Right? I don't want to write too much, but I never write just a number, right? If I did a calculation, I write the equation down that I used. I always want to make sure I read every word in the whole question, right? I don't want to answer the wrong question. I want to use my common sense. I want to approach things logically, right? If they're asking me about energy, I don't want to, bring in something about, if we're talking about energy, potential and kinetic energy for something that's kind of, let's say we throw a ball off a cliff and it falls to the ground. I don't want to bring in a mass on a spring. What does that have to do with this question? I want to be really focused on what's this question. The think like a grader is, okay, if somebody's trying to grade me on this, what are they going to want to see in the answer to this question? Right? And the best advice I give to all of my students is before you write anything, think about what you want to write. Right? Don't just start writing. On this exam, it can actually be kind of lethal. Right? Be like, all right, how am I organizing this? And if you need to use, a sidebar of your paper and you want to write a brief outline, go for it, because the better you collect your thoughts, the cleaner the answer is going to be, the easier the grader is going to have reading, okay, what were they talking about here? All right, so what I wanted to show you though is I wanted to show you an example of a free response question. All right, so this section 2, all right, this is question number 1. So this is an experimental design question. So they tell us we have a mass starting at rest at point A, the top of a slide. Right? They tell me the height h above points B and C. All right, the slide's frictionless, but the surface from B to C is not. The coefficient of kinetic friction between the box and the surface is mu k, coefficient for kinetic friction. And the horizontal distance between point B and C is x. B says find the speed of the box when it reaches point B. So now they're asking me, I left out, I took out part A because it wasn't really very intuitive, but find the speed of the box when it reaches point B. So I got to stop for a second and say, okay, how am I going to find the speed of the box when it gets to point B? What do I need to know? C then says, okay, how do I find the value of that coefficient when the box comes to rest? All right, what is that going to be? D says, assume points B and C are not on the same horizontal level. All right, so that B now has to go up to C. All right, and go back and answer the question posed in part C. So part D says, okay, we're going to change the problem and now re-answer question C with the new information. And then it says, oh, by the way, if that slide's not frictionless, now we got to talk about the work that needs to be done as the box goes down the slide from A to B. And what happens if we calculated the speed of the box at B or half the speed that we calculated back in part B? So you can see the interaction between the parts. But we can also see that if I had trouble with question D, I might be able to do E without D. So if we're having trouble with one part, move on to the next part. Right, so here I have a couple of examples of, all right, if you're asking me for the speed of the box at point B, what I'm going to do is, okay, that box is coming down a slide. We have conservation of energy. So conservation of energy says at point A, my kinetic energy and my potential energy summed together is also going to be equal to, when I get to point B, the sum of the kinetic and the potential energy at point B. And one of the main principles in physics 1 is conservation of energy. Conservation of energy shows up a lot in a lot of questions. So at point A, I have no kinetic energy. They told me I started from rest. So kinetic energy at A is 0. At point A, I'm high on the slide, so I'm all potential energy. And my potential energy is my mass times gravity times my height, h. And then when I get down to point B, I've essentially come down. I've lost all of my potential energy, and that potential energy has been converted into kinetic energy. So essentially, we set the potential energy at A equal to the kinetic energy at B, right? Because conservation of energy says I convert the potential energy at A into the kinetic energy at B. And then they've asked for the speed of the box. So the key here is, okay, solve this for VB. All right, and we now have an equation. And if you notice, the equation here is not 10 lines long. It's only 3 lines long. I might say, oh, conservation of energy, and then write it and solve it. All right. Question C said, oh, we got to determine that value of that coefficient of kinetic, that coefficient from B to C. Because once we want the box to come to rest at point C. All right. So work energy theorem says that the amount of work done by friction has to then use up the kinetic energy that I had at point B. So I'm basically going to transfer all that kinetic energy into the work or energy wasted by the friction. So I write my work is equal to the change in kinetic energy. We've got point B and point C. All right, then I find my work equal to negative mgh. And then once I have that, I'm like, oh, okay, now I got to solve for that coefficient of kinetic friction. All right, now what the coefficient of kinetic friction is part of work is frictional force times distance. Okay, so now I got to substitute a couple of equations in and then solve for that coefficient term. All right, but again, I don't have to write this in 10 lines. I can write it in 2 or 3 because there's nothing wrong with moving across the line. All right, D says, oh, there's now a slope between B and C. And now we've got an angle, an incline from B to C. All right, we've got the conservation of energy. So I'm going to have kinetic energy plus potential energy at B plus the work and energy I lose to friction as we move up is going to be equal to the kinetic energy and the potential energy at C. We set up our equation. And once again, in this case, we solve for the coefficient of kinetic friction. Right now, E was if the slide's not frictionless, determine the work done by friction as the box moved from point A to point B. And they said, and oh, by the way, if the speed of the box when it reached point B were half of the speed calculated in part B. Well, in part B, we calculated that the speed at B was the square root of 2gh. So we're going to put a half in front of that. And again, we're going to use conservation of mechanical energy. I've got my kinetic and potential at A plus the work done by friction, the loss of energy to the system is going to be equal to kinetic energy at B plus potential energy at B. Once again, we set that up and we solve for the work, right? What's the energy we lost in this system due to friction? I can't emphasize enough that the most important thing in AP exams is about the content, right? Do you understand the content and what that test is testing, right? We spend a year getting ready for these exams, right? Physics, sometimes maybe half a year for physics 1, half a year for physics 2, maybe a full year for physics 1. Different people have different schedules. So some students will spend the whole year and take physics 1 in May. Some students may do physics 1 in the fall and physics 2 in the spring, and they'll take physics 1 and physics 2 in May. right? It's all dependent on each class, the structure they've set up for the prep, and the class that they're conducting. It is a standardized test, especially with multiple choice questions in the first section of the test. But this is primarily about, do I understand the content? Do I know how to solve for what they've asked me for? Right? So the more you practice, and College Board has their website with lots of practice problems for each of the different sections on the AP exams, one of the best resources that students can access. Right? The more practice you do, the more solid you're going to be. All right. Like I said, there's still standardized tests, so things like process of elimination, letter of the day. We can still bring in a couple of small standardized test practices to help me try to maximize my points, especially when I'm not as certain about an answer. Right? So some of those will still apply, but the key to these tests are content. This is about, do I understand the content that I've spent this time learning? Right? So can I answer any questions for anybody?
You all should find the Q&A box at the bottom, or you can raise your hand as well, and I will turn on your ability to talk. All right, Patrick, you should have the ability to unmute, ask your question.
Would you be able to address more specifically the finer topics other than the big ideas? Let's say, will they be? Yeah,
Which
go ahead.
exam?
Sorry, Physics C.
Physics C. Give me a second and I will actually, I can answer the question. I just need to bring it up, the details, so that I can give them to you exactly, okay?
Thank you for your question, Patrick. And while she's bringing that up as well, you can also go on to the Princeton Review's website and you will be able to find resources for AP courses that you can enroll in. Stacy teaches some of those and other options there. You may also, if your school district or library or university or your parents' company provides Tutor.com access for you, you can find access to our AP tutors through your login credentials. And I see another question in the chat. Could you please share a recording of this webinar? Yes, because you enrolled to come to this webinar today, you will find a recording that will be delivered to your inbox shortly after this session. Great question. All right, and I'm going to go ahead and end the recording. So for those of you who are joining us via the recording, thank you so much for your time today. Really appreciate it. And I hope you have a great rest of your morning, afternoon, or evening, and best of luck on the AP exams.